you get coupling of the vibrational modes to the electrons, which include transport, current carrying capability, and ferromagnetism. So if you're going to have a ferromagnetism, you also want to have a perovskite, because you're going to get these large amplitude, low frequency bonds that interact with your electrons. So that's what we have. We have strong field. If we go to a strong field, I'm losing my train of thought, perovskite vibrational modes, and then if we can reduce the size of the grains to 3 to 12 nanometers, we have a further amplification of the motion. Then if we add in applied AC field, we can also get amplification by having the frequency match the wavelength of the billet. Now the billet I have passing around is 4 by 6 inches. And Manelas used 100 kilohertz for his frequency, and the speed of sound in the material was 10,000 meters per second. 10,000 divided by 100,000 is 1/10 of a meter, which is about 4 inches. And that's just where Manelas was winding his billet. So he was getting a physical resonance with vibrational modes, but those vibrational modes couple to the electron modes. That's what we said about the Born-Oppenheimer approximation. So to benefit from the Manelas effect, we want to have all those things going for us. And most importantly, we want to reduce the grain size down below 12 nanometers. And that's what's not been done. We think most people failed at this because they had the wrong size. So I think I've already covered a lot of this, but there's Arthur Manelas. And there's two people in the room here, Sky Gelsma and Ivan Kruglak. They gave me a power supply back when I was just finishing the EPRI research on those nanopowders giving off energy, the Ahern effect. He built a really virtuoso power supply that could give me 0 to 2,000 volts at a frequency rate of 0 to 10,000 hertz. That was unheard of, a very expensive thing. But I applied it to the nanopowders, and I was trying to do breakdown, and I said, I'll do a series of breakdown. And I burnt out the power supply in 5 seconds. And this is about a $50,000 supply. It was absolutely virtuoso. And I cried a little bit, and I called Ivan in Colorado. And I said, Ivan, I'm sorry, but I killed it. He said he'll send somebody down to help me out. And the next day, Arthur Manelas showed up. He lived about 20 miles away from me, and he showed up driving a Maserati. And he said he thinks he can fix it. So he brought a few pieces of it back to his lab in Pelham. Came back the next day driving an electric car, and we burnt it out in about 30 seconds. So he took all the equipment back to his home, and he says, you come up when I've got it ready and we'll see what happens. So I said, okay, and that was around Labor Day of 2011. Oh, so where are we going with this? Manelas produced 70 watts of continuous electricity production. No materials or fuels are consumed. The standalone device was 20 months old. That is at the time of his accident. The energy is clean and limitless, and there was a temperature drop of 5 degrees C. There's a little car. It had about 300 pounds of lithium-ion batteries in it. And we took 4 of us, averaging about 200 pounds, and we went on a long drive of 25 miles just to deplete the batteries somewhat. So the battery capacity after the trip was down to 69.6%. But when we took the car, we were weighing it at a scales at a lumberyard just to make sure there was any changes in that during the, any addition of batteries. And it was my job to make sure I couldn't be tricked. So we took the car, we put it in the yard, we instrumented it with ammeters and voltmeters. Then I put a tarpaulin on it, and I hammered it into the ground, built a fence around it, and had 2 cameras stare at it and take a picture every 2 seconds for the whole week. I said, I don't want to be, tricked. It's too important. And he allowed that to happen. So we came back a week later, and we saw the voltage increase from 168 to 172 volts. That's equivalent to 3.8 kilowatt hours. And this was the first independent third-party test of the device. I had no anticipations. I wasn't in this business. I was doing powders, and I didn't know anything about Floyd Sweet or Nikola Tesla. I just showed up with the capability. And it wasn't just myself. I brought 2 other talented engineers with me. And there were other people who, Ivan Krugak and Sky Gelsma, they were aware of Arthur Manelas years before I showed up. I just showed up with very expensive meters, which I bought with the EPRI money. The voltmeters would take a reading every 2 seconds for a whole week. Then you just plot it out. So there's the meter measuring the battery capacity before we took off, and there it is 7 days later. This is a curve of the voltage versus time over that 7-day period. And if you had thought that Arthur had done something to trick me, this should undo any possibilities of that, because you see you have a dip there, another dip there. Those dips track with the coronal mass ejection hitting the other side of the Earth, also known as the aurora borealis. That's when it hit the other side of the Earth. The first one on the left was the 4th largest of the year. The next one was the 1st largest of the year. Arthur could not have anticipated sunspot activity. So that tied that down very nicely. This is just a picture of a billet, and inside it there's a hat pin with a purple bottom, and it was just showing that this levitates. But we turned the pin around just so people wouldn't think that was magnetized, and it also caused it to levitate. But here's Arthur looking at it. Not only does it levitate, it would hold it underneath, because we learned that the pin is attracted to the point of the greatest curl of the B field, and I don't really want to touch that. This is hard to see, but there's a round circle just showing we put a neodymium iron magnet there, and you can change the field characteristics with a simple neodymium iron boron magnet. That's not very clear. This is the device. It was in the trunk of his car. Not complicated at all. But underneath that white piece of paper is where he had the billet. 4 inches by 6 inches by 1 inch, wrapped around his 3 dimensions with just regular wire. And that's the whole system. It was a few electrical components. This is like not a circuit diagram, because I didn't want to pry into his activity, but he agreed that yes, he had a 180 volt battery. He went through a DC to DC inverter down to 12 volts, sent it through a pulsing unit, coming out at 137 kilohertz. Nothing magic about that. It could be 110, 120, but that's where he got resonance. And there were 3 windings, so 2 of them went through the transformer action of the ferrite core, and we just called this the black box. It had the black characteristics, but what it would do is it would send pulses out above 180 volts to recharge the battery. And he agreed with, in general, that was the way the circuit worked. Here I have a 60-watt bulb, and it was running for 6 days on his car, and there's just another picture of it. There are the voltmeters I told you about, and right here is a thing called a hobo. It has 4 thermistors, and one of them we put right on the billet, and the other 3 just around the trunk. There's just another view of it. And here is the voltage versus time in days, and you can see that the voltage just increases slightly when that should have been depleted by at least 6 volts over that time period. This extra motion was, he was driving the car while the bulbs were going. We said, why not? But there is 4 days of uninterrupted motion, and the voltage increased rather than decreased. This is perhaps the most important measurement, and we didn't expect to see it. Here are the curves for 3 of the thermistors put around the trunk, and here's the one that was on top of the billet. That is new physics. And that is all I'm going to try and reproduce in the upcoming months, is just show a reduction in temperature. You can't do that. The definition of heat is that which flows from a body at a high temperature to a body at a lower temperature. How do you explain something cooling with no heat coming off it? So there's the new physics. Again, Arthur could never have anticipated that. Although I think Skye Gelsma, Ivan Krugak, Jim Dunn, Dennis Prefer have all felt and measured that cooling effect that Arthur found. So we just talked about the 4-day light bulb test. It was producing 60 watts, and we just hypothesized that he had some nanograins. We verified it was strontium titanate, but we couldn't see the grain structure. Arthur liked to have his billets wound with a special kind of wire. It's a central wire with another curling wire around it. I don't understand why he did that, but we have 5,000 feet of it, and we're going to continue to do the same thing, but I don't understand what that does. And just in conclusion of the talk, that I think nanoferromagnetism is at work here. That is, the nanograins of the strontium ferrite billet are the host. Magnetism is an orbital characteristic. And when you make the grains in the 3 to 12 nanometer size regime, you will get cooperative action, especially at resonance, with those delocalized bonds and the electron motion. So we can expect to see cooling and energy production by having the right grain size and doing a resonance at the right frequency. Oh, this is one last little tidbit of data. Arthur, on September 23rd, 2012, Arthur called me and he said, "Brian, I'm tired. I need help. I want you to take over the project." That was on September 23rd. And on 2 days later, his wife called me and said, "Brian, you've got to come to the house. Shut down the system. It might burn the house down." Arthur's had an aneurysm from which he never recovered. So within 2 days of him giving up on it, he died. But I ended up getting his equipment. He had taken the device apart to build 2 new ones. And I gave one of the new ones to Skye and Ivan, and I took the other one. And neither one of them worked because they didn't have the right circuit. It was a nonsense circuit. And Arthur had an aneurysm the size of a golf ball. His wife had said he had been complaining of severe headaches for the last 6 months. So he couldn't think straight, couldn't think clearly. And that's how I ended up getting it. But even though still, we took his device, and the black curve is how a battery loses voltage over time when it was running at 10 watts. Over 14 days it took to go from here to here. It was dropping 0.08 volts per day. I would measure it every morning at 7 o'clock. I did that for a couple of months because I just wanted to see how repeatable it was, and it repeated itself. But then one morning I went out to take my dog for a walk. I went out at 7, I came back at 10, and it was here at 7, it was there at 10. I don't know how it got there, but it went up by 1.1 volts. Just like Arthur said to me in April of 2012. Brian, my batteries, they pillowed out. They almost burnt the house down. He didn't know what happened, but it happened between midnight and 6 a.m. on Sunday in April of 2012. Mine overcharged because that was a full charge. It went up beyond that, and it did it in a 3-hour period. Now that would have taken over a kilowatt of input power to do it, and my wires wouldn't take it. But what we learned soon thereafter is within that 3-hour period, the Japanese had discovered the first light of a nova, the largest nova explosion ever recorded in our galaxy. Because you don't record most of them, you just happen to be staring at the right time when it goes off. That was a magnetic effect on the billet. The ones I showed you before, the 2 dips, those were a magnetosphere event. So there are things about magnetism that we don't understand. And one of my mentors was named Henry Colm. He was the co-founder of the National Magnet Lab at MIT. I used to visit him about once a month, hoping to learn more about magnetism. And he said, Brian, at one time, I think I was the most knowledgeable person in magnetism on Earth. He says, not true anymore, I'm 87 years old. He said, but we recognized there was so much we didn't understand. So there's still a lot to do, and there's still a lot to learn about magnetism. And I'm here to tell you that this Manelas device works. I'll take it to my grave that it works, and so will the people who work with me. And we want to expect you to want to do the same thing. All it takes is a nanograin billet and some wires, and to show a decrease in temperature by 1 degree C. So that's what my plan is, and I hope you can appreciate it. Thank you very much.
Okay, now we'll do questions and answers for Brian.
Brian, I can't help asking you, as you proved to us that there's, first of all, there is this electron-nuclear coupling, which is a very important physics discovery, especially with the frequency and amplitudes you're talking about. I'm wondering if you can hypothesize about the energy source being nuclear, or is it a nuclear interaction with the vacuum?
I'll just take a stab at it. I'm pretty good at this right till I get to magnetism. I know magnetism is there, but I don't know how to discuss it or describe it. But I had a conversation with a fellow named John Wallace just 2 days ago. John has spent his whole life making measurements in iron. He's called castings analysis, and for the Navy and the Army and so on. If they want to know if they have a good casting, they send in a signal, electromagnetic wave, into steel, iron, and he tries to understand the response. And he says, with most metals, you get an expected result, but with pure annealed iron, there's things he can't explain. And he's seeing, he believes, a new state of matter called a Bose-Einstein condensate. He thinks the iron acts in this fashion, and he thinks it accounts for the cooling and the energy excess. But then Tom has suggested that, well, if you get a coupling between the electron motion and the vibrational modes, and those vibrational modes are already in their lowest vibrational mode, they're in what's called a zero amplitude mode, what will happen if you try to reduce that? Now you've got the coupling to the electrons. The electrons cause ferromagnetism. If you make the spins misalign, that is a cooling effect, and you have to lose heat, but you can't. So that's when 0-point energy comes in as an answer. I don't understand it, but how do you take energy away from something that is forbidden by the Heisenberg uncertainty principle? So I don't know how to describe it any more than that.
Do we have more questions? If not, I also see a device down here. Is there going to be something with that?
Hi, ma'am.
Here's the billet. I want everybody to touch it.
With the billet, you mentioned an equation. It was the speed of the sound in the material divided by the speed of something or other, and that resulted in a billet length of about 1/10 of a meter. But can you go over that equation or say that?
It's just the speed of sound divided by the frequency of the input equals the wavelength. So wavelength times frequency equals C.
Do we have more questions?
Brian, do you have any explanation for the astronomical events interacting with this billet?
Yeah, I want to highlight that. These are astronomical events, not astrological events. No, they can get confused. I mean, if you believe in extraterrestrials, you can get thinking this is some voodoo magic. But no, it's just a magnetic effect. A coronal mass ejection hits our magnetosphere and causes a very strong interaction. And that's what I wanted to say, that this is an astronomical event. And what could have been coming from that nova 800 light years away? Well, it came at the speed of light, but what was it? What were the magnetic characteristics?
It's a pulse of some electromagnetic.
Well, it was an explosion, that's for sure, and they just saw the first light of it within that 3-hour period, but who knows? I mean, that's not something you can study because you can't predict what a great nova is going to do. But we hope to be able to get at it at the lab by making magnetic measurements.
Last question. When you're talking about this nano 5 to or 3 to 12 nanometer nanograin size, does that mean that the billet we see here needs to be manufactured from a powdered nanometer size mixture and then somehow solidified or compressed into ferrite?
Ferrites are manufactured in certain sizes by grinding to powder and then hot pressing. For strontium ferrite, the preferred dimension is 100 nanometers. But there's a distribution of sizes. So you can have it from 10 up through 100. It's only by just happenstance that you could get a high concentration of 10 nanometers. But their goal is 100 nanometers. So it's not that difficult to get there. I have Chinese producers that stand ready to do it. And press into a billet, yeah. That's the easy part. Making the powders is the hard part. Oh, I also wanted to make you aware, when I was doing the Ahern experiments where I was shooting nickel nano powders, I was doing a mortar and a pestle, and I got some in my forearm. It caused partial paralysis for 6 months. So if you were going to work with nano powders, I can't tell you you shouldn't do it without protection. And that happened to me. Excuse me, did you ask a question?
Yes, I would like to. First, let me thank you, and all of us do thank you, for telling us about this. This is really very interesting, and we're grateful for presenting it. You know, this cooling, this anomalous cooling has been reported from time to time with a variety of devices, but your measurements with the thermocouples is by far the best documentation I've seen anywhere on any device. And that's particularly informative. But let me just ask a simple question for a clarification of something I didn't hear quite right. When you saw this rise in voltage in your battery, what was it connected to? Was it connected to a working billet, or what was it?
It was connected to the power supply that you saw in the trunk. That was the only thing that was running. And it was running at about 25 watts. But it was putting back in on the order of 50 watts.
Okay,
So-
so this was his actual power supply
It was his power supply, yes,
that was still intact?
yes.
Okay.
Hello, and thank you. I wanted to ask about the possibility of the continuous action of lightning occurring around the globe at, all the time, and possibly creating a certain level of energy that's possibly usable that we could count on instead of going for the astronomical.
Astronomical is not something you can count on for sure. We were very fortunate to see those dips track with the coronal mass ejections. I forgot your question, though.
Well, it was about, we have a certain amount of...
Could you step to the mic when you...
No, I
so-
remember now, I remember now.
So everybody can hear the benefit of your conversation, please?
Yes. That we have a certain amount of lightning striking around the globe at any one moment, and it activates I believe it activates the atmosphere. And is that something that could be possibly tapped into or used on a regular basis? It's seemingly there all the time.
I agree that there's a lot of energy there. The electrostatic fields that are produced with just the atmosphere are enormous, but I think they would only result in noise for the magnetic aspect of it. I don't see that as a source of magnetism being useful.
Did Arthur Manelas know about the work of Sparky Sweet?
Oh, for sure. Oh, geez, he had his books. Arthur said, I don't understand how this works. I don't know why it works, but it works. That's what he said to me.
Did that guide his research, what Sparky did?
He took a lot of what Sparky did, word for word, and as close as he knew how to do it. I don't know what he did different, but it might have been just as little as he got a strontium ferrite billet that had the right grain structure.
Did he talk about how he conditioned his strontium ferrite?
Yes, he did, and he did it with just neodymium iron boron magnets.
Did he do anything with the material to force smaller grain sizes?
No. When I was privy to his writings and papers, he had several papers on nano-grained ferrites that he was looking at. That's why he came. He agreed to come to see me because I had a reputation among something I formed. I formed a lightning club, and I would have everybody in New England of interest come to my house once a year. And Ivan and Sky knew about this, and Arthur heard about my lightning club adventures and my interest in ferromagnetism. So that's why he came to help me. He wanted to learn from me, and I was very glad to have his help.
So, as far as you know, he did nothing special about making that billet.
No, he did not. No, he did not.
Okay, because Sparky Sweet was very, very secretive of how he conditioned his barium ferrite blocks.
I think he was doing the work before neodymium iron cobalt magnets, and he just didn't have the field strength to coerce the fields.
Yeah, he was working with barium ferrite, which you can't get anymore.
I don't think the barium has anything to do with anything, or the strontium.